And we're live! Wow, it always catches up on me every week. I'm never ready for it. And then all of a sudden it's 2 o'clock. Or wherever you are, it's 4 o'clock on the East Coast, and it's really late at night and overseas. We got somebody here from the UK, which is awesome. So thank you for coming. You can happily take the rain from England, says 3D printer guy. Yeah, here in Colorado, we've been in a severe drought for years. We just get sporadic rain, and it's never enough. We're killing trees left and right. We have water restrictions. We have got everything. It's it's like a biblical plague here, but we are enjoying rockets, and this is RockSim Live. This is where we talk about RockSim software, RockSim Pro, and the launch visualizer, and this is where we answer your questions that you might have about using any of those applications. My name is Tim Van Milligan. Okay, so let's get started. I've got a computer monitor over here, and this is where I am looking. Every week I have microphone problems, and the first comment is, I can hear Tim, I must be dreaming. Which is reference to the problem that every week we have with the microphone. So I'm glad the microphone is working. I did bring a spare microphone, a USB microphone, just in case my lapel microphone's not working, but apparently it is, so great. We have somebody, Fat Bank from Texas. Cyrus Space, it's 2,200 hours in Germany, 10 o'clock at night. Wow, you guys are up late on a Friday night. 3D printer guy is in England. He's got 9 p.m. Wow, you guys are dedicated. Glad to have you here. So where do we get started? If you have a question, go ahead and type it into the comments, and I'll answer. 3D printer guy says we have about 100 meters worth of string and send a rocket car flying down. Last one went 82 miles per hour. Oh, okay, he's launching rockets horizontally on a car. Okay, I get it. Okay. If you are unfamiliar with RockSim, let me show you my desktop here. You get RockSim at Apogee Components. This is our website, www.apogeerockets.com. And I got to turn off this because I'm getting pop-ups popping up on me. Got to quit some things. Okay. Apogeerockets.com is our website. When you get here, we have this banner bar at the top, and if you scroll through the banner bar, you can find RockSim. You can find kits. You can find the launch visualizer. This is the quickest way. It's also available at rocksim.com. And our newsletter. And we like people to sign up for our newsletter. We don't spam. We send out one email a week on Tuesdays. What we do is the newsletter is we fashion it after how-to information, like how to do RockSim or how to do rockets, how to install igniters, tips and tricks, and we alternate it. One week we do a video, the next week we do a PDF version of the newsletter, which we like to do it at PDF because you can print it out and it gives you something to save. A lot of people we know put them in binders. We are on let me see what issue we're at right now, 574. So you can theoretically print out 574 issues, put them in a binder, and have a really good collection of rocketry knowledge. I mean, that is like the encyclopedia of rocketry right there. We also have videos. You'll see our latest how-to videos down here. But we're here to talk about RockSim. So we are doing RockSim Live right now, RockSim Training Live, which you can see right here. If you click on that link right there on the home page, it will take you to our archives. We are on episode, I think we're on 72 right now. Episode 71 was the May 27th, and today is June 3, so that makes sense. On this archive page, you'll find the link to the video, and these are the topics that we have, and at the timestamps where they are in the video, so you can just go to that timestamp, you know, designing a helicopter recovery rocket. In that video at 38 minutes and 2 seconds, you'd find that topic. So there's all kinds of topics here. If you're looking for something in particular, what I do on this page is do a Control F for find, Control F, and it brings up a little search bar at the top of your screen right here. On the Mac, it's Command F. And then once you have that search bar, you can search for a specific term, like about like sweeping fins. Okay, so I started typing sweeping, and look, making forward sweeping fins. You know, in that edition, you know, episode 65, at 45 minutes and 34 seconds into that video, you'll find out about how to make forward swept fins. So that's where you find our RockSim Live training. To download RockSim, like I said, you could either click on that banner link, or you can come down here to How-To Guides, come to Software, and you click on that, and you'll get this menu where you can get the free trial. There's video tutorials in addition to the RockSim Live training, so there's multiple videos. Here's our RockSim Live training. You know, FAQs, version history, system requirements, all the stuff that you might need to know about RockSim is right there. All right, so let's go to the chats and see what kind of questions we have. Oh, there was one question that came in via email, so I'll answer that one, and that was from Carlos. And he wrote, he was confused by, you know, the terms root chord, tip chord, semi-span, things like that. And those all have to do with trapezoid-shaped fins. So first let me bring up RockSim. I haven't started RockSim yet today, so I'm going to start it up from scratch. Okay, this is what it looks like when you start. You get this splash screen, and if you don't like to see it, just hit the escape key, and it will just disappear as quickly as it appeared. Now let me make sure that we're seeing the screen here. Okay, I don't want to cover up my face down here in the bottom, or I don't want my face to cover up important information that's here. Okay, so to open a design, click on the File Open button right up here. We had another question from somebody that asked, where are the RockSim sample files? And they are located in the RockSim design folder. Let me show you how to get there. First you gotta, I'm on the Mac, but on Windows it's pretty similar. You gotta go to your applications, where all your applications are stored. On the Mac, it's in the applications folder, which is right here in the menu. On Windows, you go to C drive, and then the folder called Program Files, in parentheses, x86. I have no idea what x86 means, but that's where they're stored. And then you would sort it by name, so it's alphabetical, and then come down to the RockSim. And I've got many versions of RockSim on here. Right now on the Macintosh, our latest version is still 10.3.0. No, it's not 10.3.0. It's yeah, I guess it is 10.3.0 F63. But there's a new release that I'm using that we haven't released for the Mac yet, and that's because we having problems with Apple Computer. There's what's called a signature, and that verifies that the software is legitimate, that it came from Apogee, so that when you install it on your computer, it doesn't give you all kinds of warning messages saying, you know, are you sure you want to download and install this? We want those to go away so that installation is real easy. So that's why we're holding it up, but I have a pre-release copy. So inside of RockSim, inside that folder, you will find a folder called Designs. And this is where all your RockSim samples are. And they're listed here by manufacturer. So there's a whole bunch of manufacturers in here. You know, you got Aerospace Specialty Products, ASP, Aerotech, Aggressor Aerospace, Apogee Components, which is, you know, the one that you should be in the most often, hint, hint. There's a few Estes ones. So these are the sample designs. And if you want more, there's thousands of them on the internet. So like you can go, you know, pick your favorite rocket, you know, like, I'm trying to think of a rocket that's not so common, but I can't think of one. So I'll just go Aspire. Aspire. I got to type it RockSim file. Just type in your search bar. Just type that in and hit return, and that will bring up Google, and it will give you all the RockSim design files. So like the first whole bunch of them are Apogee. Man, they're all Apogee. Okay, yeah, but you can find a lot of RockSim files on the internet for your favorite kits. So if you don't find them in here, you know, like in the Estes folder, you know, there's only a few. And these are the ones that I put in, but other people have done Estes kits already. So yeah, so here's a doorknob rocket. You know, and it looks pretty simple. But we were talking about what root cord and tip cord and all that stuff pertaining to fins, all the terminology. What does that mean? So I want to open up the fin. So I'm going to double click on the fin. And that will open up the fin editor screen, which is what you're seeing right here. And in the general tab, this is where you start seeing those terms like root cord, tip cord, sweep length, sweep angle, semi-span, and location. Okay, so I've got a rocket here. And this one has a trapezoid fin. Now a trapezoid, remember, has two parallel edges. And you can also get elliptical in this screen, but some of the fields went away, obviously, but you still have root cord, semi-span, and location. But let me go back to trapezoid. And these are pretty easy to figure out. First of all, the word cord means, let me type it in Google and see what Google cord definition. A group of notes. Yeah, that's in music. We're not doing music, but this is an aeronautical term, so it's a geometry term. It's a line segment joining 2 points on a curve. So when we're looking at a cord, we're looking at the edge of the fin. If you were looking straight onto the edge, that is called the cord, a cord. There's infinite number of cords along the length of the fin. It's just each layer, if you sliced it, would be a cord. So now we're just saying, what's that length of that cord? So let me go to a side view here, and you see the side view of the fin. And the first one is the root cord length. So what is the root cord? So root is like from a tree, you know, where they go into the ground. So where the fin goes into the body tube is called the root edge. So it's kind of like the root of a tree. It grows out of the trunk. So here's the trunk, and the fin is growing out. And it's always called the root chord because it kind of says that's the side that's buried in the tube. So now we need the length of that cord. So what we're talking about is from this tip here to the back edge right there, where it attaches to the tube. Only where it attaches to the tube. And that's the root chord. And then the tip chord is the opposite. So on your rocket, let me make it a little bit bigger here so you can see it. The tip chord is the furthest away, the tippy edge. This is the tip chord. And so now it's just the length of that, and you can play with it. So I'm going to take this tip chord and I'm just going to grab this slider bar here and just slide it backward. And the only thing that I'm changing is the tip chord length. And you can see exactly what's happening with that tip chord length. I can make, oops, I'm grabbing the wrong one. Oops, I'm grabbing the sweep length. Okay, so here's the tip length, and I'm just making it longer and longer and longer and longer and longer. And I can make it shorter and shorter and shorter, and then finally the smallest I can make it is 0. And at 0, it's just a little point. So any of these slider bars you can adjust, and you can instantly see what you're changing just by looking down at the screen at the bottom. Okay, so root chord length. Okay, so sweep length. Sweep length and sweep angle are two definitions that control the same thing on the fin. Now the sweep length is, okay, imagine a straight line emanating straight out of the body tube, going straight up, perpendicular to the tube. So if you go straight up, and then if you take a ruler and you measure from the line to the tip of the fin at the tip edge, so that length from here to here, it's an imaginary line, but what is that length? And that's called the sweep length. So if I make it 0, let me type in a 0 here. What happens? You know, the line is straight up, and if you drew back exactly to that point, it's 0. So that's length. So sweep length is pretty easy, and it can be a negative number. As you can see here, I got negative 3.37 inches, or it can be a positive number. And so, but like I said, sweep angle is also basically controlling that same amount of sweep. And instead of measuring it as a length, we can measure it as an angle. So a 0 degree angle from here, let me change that to 0 degrees, is straight up. So we're measuring from this line backwards. And let's make it, the biggest we could make it would be 90 degrees. And let's type in 90 degrees for this angle. And as you can see, it doesn't like 90 degrees. Let's try 89. You can see it's the sweep angle is almost flat. It can't do flat. I can probably do 99.9 though. No, well, you can see it did it, but they're way out here. It's just too far. But that is sweep length. So when you change one, you're actually changing both of them. Okay, and then the semi-span is the distance from the body tube out to the outer edge, to the tip edge. It's just measured straight down. So if I make the semi-span 0, it doesn't like 0. Let's make it like 0.5. See, here's 0.5. So this is measured from here to here is 0.5. I got to turn my phone off because somebody's texting me. Okay. Yeah, so that is semi-span, and you can take the semi-span slider And as you can see, RockSim is redrawing the rocket on the fly, making the semi-span. Right now I have a semi-span of 20.75 inches, so that's from the tube all the way out here to that tip edge and anything in between. So hopefully that gives you the definitions. If I change it to elliptical, the root chord, again, the root chord is that length there along the body tube. The semi-span is from the body tube out to the furthest tip, and that's really all that we can change. Now location is where on the tube the fin is located, and right now it says the location is 0, but there's a reference point. You got to remember what this reference point is. And somebody emailed me this question also this week. He was changing the length of his rocket, and the fins weren't staying attached to the rocket where he wanted them. They were kind of floating around. And the reason for that is right here. It's where the fin is referenced from. And right now our reference point is from the base of the owning part. Now these fins are owned by the tube. That means that they're attached to the tube. That's the attachment. And we're saying we're 0 inches from the base of that part. So right here is 0 inches from the base of the owning part, which is that tube. And your other option is you can make it from the front of the owning part. So now you see the number changed. We went from 0 to 13.62 inches. So it's 13.62 inches from that point right there at the base of the nose cone to the front edge of the fin. And then the third one is from the nose tip. So now we're measuring from way out here to the front of the fin. So it's pretty easy. You just take the slider bar and you can slide it around, and you can see these numbers are changing right up in here. And if I make it from the base of the owning part, that's there. Change it back to 0, and you can make it. You can make these numbers negative as well. So you just have to type it in. So I can make it like a -3 inches, and what happens is now it's measured 3 inches from here to here. And putting in negative numbers is a useful trick in RockSim because it allows you to do things that you normally can't do. So like, for example, I can, if I go from the front of the owning part and I make this a 0, where's it going to put this fin? When I hit the tab key, whenever you enter a number here, you got to hit the tab key, and it will jump. That kind of tells RockSim that you're done typing. Now let's see what happens. So when you type in a 0 from the front of the owning part, it's right here. But now if I make this a negative number, where's that fin going to go? So -3 inches from the front of the owning part, you can see that it moved way out here. And if I zoom in a little close, you'll notice that the fin is not following the curvature of the nose cone. But we can actually, RockSim will allow you to do this. And if you want it to follow that edge, what you've got to do is grab the slider bar right here. And as soon as I grab the slider bar, you can see that it followed the edge right here. It's doing something weird back here, but it is following the edge right there. And then from this point, if I move it around, I think it's because it has a fin tab right here. And that fin tab, let me turn that fin tab off. That's through the wall fin mount. If I go to that tab, you can see that it has a tab here. So I'm going to turn all these to 0, and that will turn off that tab. And then hit tab, tells it I'm done typing. Then I'm going to go back to the general tab, and if I grab this location, okay, there, well, it doesn't know what to do with a trapezoid or an elliptical fin. Let me go to trapezoid. Oh, okay, that's kind of weird. So here's a trapezoid fin. Let's try negative 5 inches. You got a little issue there. Doesn't want to follow the curvature like it should. Oh well, another issue that we got to fix. Yeah, when you're doing geometry, there's a lot of math involved, and RockSim does it all behind the scenes, but sometimes it gets a little confused. Okay, so that is the definitions of root chord, tip chord, sweep length, changing the location. Oh, one of the things is the fins not following where they should when you change the length of the tube. So if you have the fin location specified from the front of the owning part, and click OK, and then if I go to edit the body tube, so I'm going to go here to Rocket Design Components. I could also just double click here, or I could double click here, and that will open up the editor of the body tube. So now watch what I do when I change the length of this body tube. Now the fins are referenced from the front of the body tube. So if I change the length of the body tube, the fins, they look like they're moving, but actually they stayed the same because they're still the same distance from the front of the part. If you want them to move like the engine mount, then you need to reference them from the base of the part. So let me cancel this. And then go to the fins again. Open the fins, double click on it. And I'm going to just, the only thing I'm going to change is from the base of the owning part. Click OK. Now I'm going to edit the tube again. Double click on it. And now as I change the length, the fins follow the length of the tube. So that's your little shortcut to make sure that your fins stay in place when you adjust the length of the tube. And so all the parts that are attached to the tube will have that location field. And so like there's a parachute, there's a launch lug, there's an inside tube, there's centering rings, there's engine blocks, there's mass objects. They can all be referenced from the base of the owning part. And on this design, they obviously are, because when I'm changing the length, you know, the only thing that's changing, you know, everything is referenced from the base so that it stays the same distance away from it. Okay, so that is another nice little tip to learn. Okay, so let me go back here to my comments. There's a whole bunch of comments that came in. Let's see what kind of questions we have. We have Tom, says, good afternoon from Virginia. 3D printer guy from England says, could you design an HP rocket, which stands for high power, and explain fins, how to perfect them, making the most efficient one, giving the least drag while getting it high? Okay. This is a question that's always hard to answer because it has to do with drag. You know, if you want to make them the most efficient, what you're and by efficiency, you've already specified that it means going as high as possible. So to go as high as possible, you have to minimize drag. So, so the question is, how do you minimize the drag of your fins? And this is a very hard question to answer because it has a lot of fingers to it, a lot of tentacles. First of all, the Achilles heel of RockSim and pretty much any program currently available that I know of is that estimating the drag is very hard because drag has so many variables that affect the overall drag of the rocket. You have the big ones are speed and angle of attack. And so there's certain fins that operate best at high speeds, and then there's certain fins that operate best at low speeds. And that has to do with the chord shape. Remember that chord? This chord right here? You know, if on this particular rocket, I'm looking at just a rectangle as my chord shape. A rectangle is, and they call this chord, it has a specific name, it's called the airfoil section. And a rectangle is a pretty poor airfoil section at any speed, but we use it in rocketry because it does work and it's easy to build. And I build most of my rockets with a rectangular airfoil because they photograph pretty good, because you get a nice sharp edge no matter which way you're looking at the rocket. If you round everything off and you take a photograph of it, the edge may look a little bit fuzzy, and that's the real reason why I make mine with square front edges. It's not that they fly better, in fact they fly worse, but they fly okay. So it's good enough for what I'm doing, and for me, I'm trying to sell rockets, so I want something that looks good in a photograph. But when you get into what is the best airfoil, it depends on the speed. On a low speed rocket, something with a rounded front edge and then comes down to a teardrop shape at the back, so it's rounded at the front and comes down to a wedge at the bottom, is a pretty good low drag airfoil. At high speeds, like as in supersonic rockets, you want a knife edge on your front edge, but a knife edge on a low speed rocket is not so good. So you can see where we're getting here is, like, how do you design the best shape fin in RockSim when you really can't control the airfoil? And so now you're saying, okay, what's the best shape of the fin? Well, in that case, again, it depends on the speed. On this particular rocket that you see here on the screen, we have a rocket fin that is swept aft. And fins that are swept aft are good for high-speed flights, like supersonic. You know, like all supersonic jet airplanes have wings that are swept rearward. And that, what it does is it prevents the tips from stalling at high angles of attack. So you get, you know, it has benefits having swept fins. But for low speed, you don't need to sweep them. You know, remember that trapezoid? With a really good low speed fin has a sweep angle somewhere like this. That's a good low speed shape. What's even better, and that looks pretty similar, would be elliptical, like that. You know, if you just kind of like, instead of making everything nice and round, if you just had, you know, straight lines everywhere, it would turn into a trapezoid. And the elliptical fin is the optimum shape for low speed rockets. And the question we get all the time from every kid in the country that has to do a science project, they want to know what's the best shape fin. And the answer is easy. Elliptical fins, like this. And if you want to know the reason why, we do have a newsletter article that talks about that. Apogee rockets. What you do is you go to best, yep, there it was, optimum shape. So technical publication number 16, and it's also in a newsletter. We put it in this newsletter right here, and it says download it now right there. So click on that, and it is newsletter, oops, I was trying to move that up. Newsletter number 442. What is the best shape fin for a model rocket? And if you get into it, let me make this a little bit smaller so you can see a little bit more. So here's the elliptical, here's a trapezoid, here's a square, rectangle, clip delta. You can have, there's an infinite number of wing shapes that you can have. But like I said, what's more important is the airfoil cross section. That's going to determine the lowest drag and the highest flight. So don't get too hung up on the fin shape. It's not that critical. What you should get hung up on is the airfoil cross section. You know, like this shape. If you cut a cord off and you looked at that edge, you know, on a model rocket, it should have, you know, a rounded leading edge and comes back to a knife edge on the back end. That's a good airfoil. And if you read this article, it tells you why an elliptical fin has the lowest drag. And it's called induced drag. When you induce drag, what it means is the drag is induced, which means it's caused by, and it's caused by lift. So as the rocket's, you know, if you look at it like this, if the rocket is at an angle of attack, which means that the nose is slightly high, but it's actually going horizontal, that would be an angle of attack, and that produces lift. When it's straight on, there's really no lift. But as soon as you have even a small angle of attack, you'll get induced lift, which is a good thing because that helps stabilize the rocket. But you also get induced drag. And so what happens is you get a low pressure on one side of the rocket, then on one side of the fin, then the other side. You get low pressure on this top surface, high pressure on the bottom. And so air doesn't like that, and it wants to flow around the tip of the edge instead of going around this way. And when it goes around the tip, what it does is it creates a vortice, you know, circular air, like you see here in this picture. This is air coming from one side and it's flowing around the tip edge to the other side. And so whenever you got a vortice like that, that's extra drag. Because what you're doing is you're changing the direction of flow of those particles of air. And Newton's third law of, what was it, the third law of motion, it says whenever, no, it's momentum. Momentum is the second law of motion. Whenever you change a particle's momentum, it takes a force. So force equals momentum change. And that's where F equals ma comes in. And so what we're doing is it took a force to cause those particles to go in a circular direction, and that force requires energy, and that energy comes from somewhere, and it comes from the motion of the rocket. And so we're robbing speed to create vortices on the fins, and we don't really want these vortices, but they show up as drag because it's slowing the rocket down. An elliptical shape has the lowest induced drag, and that's why it's the optimum shape. And if you can read that article, you can figure it all out. You know, like the worst fin shape would be this one right here, where you have big or very large tip chords. So here's the tip, a very large tip chord, because that would give you high induced drag, and we want low induced drag. So that's my thoughts on designing fins for high-speed rockets. Worry about the airfoil. That's the most important part. Really sand in those airfoils. Know what speed your rocket's going to travel at. If you're going to go supersonic, you might want a supersonic airfoil. You know, with a, you know, you've seen them on rockets like the Nike family of rockets, like the Nike Smoke. The airfoils are a diamond shape, so they got a, you know, if the tip is up here, they come down outwards and then they come back down to a point at the bottom. So you get a diamond shape. That's a really good high-speed airfoil for supersonic flight. So you use RockSim to find how fast your rocket's going to go, and then start worrying about your airfoil shape, because that's the most important thing. That was a long discussion. Okay, Cyrus Space says, I launched the Firefox SHX rocket a couple days ago. It was a beautiful flight, a great rocket. Okay, so I got to show the Firefox. So if you go to the Apogee website, apogeerockets.com, you go to the search bar and you type in Firefox, and you'll see it pops up right there. You just click on it, and this is what the Firefox looks like. It just looks like that cool rocket right there. Here's a picture of me holding it. Here's one flying, and Cyrix, I'm sure he has a great image of his rocket taking off. JJJ says, anybody from the Cleveland area here? I don't know. We'll have to keep reading. 3D printer guy, I did my G84 rocket also since you were last live, and man, it went far. You could feel the power. It was great. Yeah, G84, that's a high power motor. At least it requires high power certification here in the United States, because it's greater than a G80. Tom writes, does RockSim always assume that fins are aligned vertically? If the fin was to be canted, what flight data will RockSim predict? Okay, so that's a question I can answer. So in this rocket right here, yes, the simple answer is in RockSim, the fins can't be canted. They always have to be parallel to the body tube that they're attached to. So you're not going to see roll stability in RockSim. And the reason for this is because RockSim is a 3 degree of freedom program, and that means it calculates the direction of the rocket in 3 directions. And the one is up and down, so that's one. And then the next one is this way, you know, kind of like into the wind or away from the wind. So that's the second direction. And then the third direction is pitch. So it's a rotation direction like that. So you got up and down, upwind, downwind, and pitch. If you're going to cant your fins, you need 6 degrees of freedom. So you need roll. So roll would be another direction. Yaw, well, if pitch is this way, yaw would be into your screen or out of your screen. So that's 5. And then the last one is, it can be translate crosswind, this way or this way, where the wind is coming this way, we're going into or, you know, across the wind. So that's 6 degrees of freedom. If you want to do that, then you need RockSim Pro, or we call it RS Pro. Let me launch RS Pro. The launch visualizer also will calculate roll stability, but you need to create a design that has canted fins, but you can only create those in RockSim Pro. So I'm going to open up that design that we were just looking at. That was the Estes doorknob. So again, if you recall, applications folder, you'll find the RockSim folder. And then inside of there's the design folder. Open that. Then I'm going down to Estes, and we have the Estes doorknob. So I just want to have the same rocket that we were just looking at. You know, it looks pretty much identical. So in RockSim Pro, I can cant the fins. I can cant them in the back end, but you're not going to see it in the front end. So you're not going to see it in the user interface where these fins are canted. But I can cant them anyway. And I can do that by going here to the fins, editing the fins, double click on them, and here's where RockSim and RockSim Pro are different, because they both have radial position, but under the radial position in RockSim Pro, you'll see a fin cant angle. This is not in RockSim. It's only in RockSim Pro. So I can cant them. So like maybe I gave it a 5-degree cant, and then I need to set where the pivot point is. So if I look at my fin, am I going to pivot at the tip? Am I going to pivot in the middle? Or am I going to pivot at the back? It really doesn't matter that much. On this fin, it has a root edge of 4.5 inches. So the middle of that fin, right here in the middle, would be half of that, which is 2.25 inches. So I'm gonna make my pivot point here 2.25 inches, 2.25, and hit tab. That tells RockSim I'm done typing. If you look at the 3D image of the rocket, it looks identical. The fins still look like they're straight along the tube, but in the back end, RockSim knows that they're canted. And so now, if I launch this rocket, like Tom was saying, is that going to roll the rocket? And the answer is yes, in RockSim Pro. So what I'll do, so we got the rocket. I'm going to save it as a different name. Save as doorknob, canted fins, and I'm going to throw it on my desktop just so I know where it's stored. Hit save. Now we're going to launch it. So to launch it, you go up here, prepare for launch. We're going to choose an engine, and I would like something that has fairly good long burn to it. So I'm going to go here to the burn column, how long the motor burns for, and I'm going to sort the list by the burn time. And so now it's sorted by the smallest to the biggest, so I'm just going to hit it again, and now it's from the longest burn time to the shortest. And these are some really long burn times, and I wouldn't use these for most normal rockets. I'll try the G25. I think that would probably be a good motor. And let's say it's a 10-second delay. And we'll click OK. And now let's see how the rest of the simulation is set up. The parachute was deployed at maximum ejection delay. Starting state, 36-inch launch rod. It's at an angle of 8 degrees. And it's an angle of 8 degrees. This is like a compass. So north would be straight up, east is at 90 degrees, south is at 180, west is at 270, or at minus angles or minus 90. Let's say that this rocket's going to be launched to the northwest. You know, this would be the northwest going off that way. Simulation controls, leave that alone. I'm not sure where this launch site is, but it's somewhere in the northern hemisphere. It's not in Colorado, but it's a little bit further north than we're at in Colorado. But let's get rid of the flight profile and see what the launch looks like. And by doing this, it will load the simulation, and so we'll be able to see how the rocket looks with canted fins. Okay, so here's the rocket sitting on the launch pad, and I can't tell where I am, so I'm going to zoom out using the scroll wheel on my mouse. I can start to see the field right here. We got a parking lot, we got some baseball diamonds over here, probably soccer fields over here. We got an interstate down there. North, you see this black arrow down here in the corner? It points to the north, and I can swing this around so that north is straight up. So now north is off here to the top of the screen. And remember, we're launching this rocket to the northwest, so we expect it to go this way. You can see the rocket on the pad, and it does have a tilt angle to it. So let's first get an overall view of what this rocket looks like. So we'll just click the play animation button right here, and the rocket takes off, and you can see the smoke coming out, and the green line is following the trajectory. The rocket's going over the top, getting up there at the top at 10 seconds. Well, it should be around 15 seconds because this was a really long burn time. The parachute should pop out. Okay, so somewhere right there. Parachute pops out, and now it's starting to descend under parachute. Okay, so I'm gonna go back to the beginning, and now I want to look at a close-up view of the rocket. So I'm going to turn off this view because I want the same view. I'm going to just zoom in. So now when we watch the rocket, we canted the fins, so we expect to see it roll. So here we're going to click play, and you can see that the rocket is spinning. You know, the fins aren't staying in place, and you can see the launch lug. You can actually look at the launch lug. It's easier to follow. The rocket's rolling, and it looks, if you were looking from it from the base, it would be spinning clockwise. Let's see that again. So back on the launch pad, click play, and watch the launch lug come around. You see the launch lug there? It's spinning clockwise. Okay, so let's stop that. And I remember I saved this. I'll save it again, and then I'll open it in the launch visualizer because you all have access to the launch visualizer. I need a new window, new browser window. And we'll just go to rocksim.com, and that will bring up the launch visualizer. And what we're going to do is we're going to load this same rocket into the launch visualizer, and then we can see, we can see the exact same thing. It's still loading. Okay, so I need to log in. To be able to upload, you need an account, and the accounts are free, so you can just log in. And I'm going to use my login. Hit sign in. Okay, so now I'm logged in as me. And so if I go back up here, you can see I'm logged in under Tim Van Milligan. And then I come right here, and I can say upload new rocket. And I say, well, browse for the rocket. And it will look on my desktop. Here's my desktop. And I want that Estes doorknob canted fins. Open. And click upload. And it was uploaded successfully. And then it's going to redraw the rocket right here on the pad. So there's the rocket. And now this has been saved with canted fins. So let's choose a launch site. And I think that launch site was Huron Valley. Open. Let's see if it's the same launch site that we just had. Yeah, because there's the baseball fields. So now we're actually in the parking lot. I think before we were launching from right about there. So you just double click on the map, and that puts the launch pad at a different spot. And let's say confirm that launch site. So click that button there. Okay, so that's our launch site. And then we were flying with a G25, was it? We were like 8 degrees from vertical, somewhere around there. And we were aimed to the northwest. And, okay, choose an engine. I don't remember what our winds were. I think I want to find that G25, so I'm just using the search bar up here at the top. Here it is, G25, and it was a 10-second delay. Click OK. All right, so we have the G25 loaded, 10-second delay. Make sure our parachute is deployed at max ejection delay, and then just click launch. And why is my simulate button not active? I think we have a problem here. Somebody emailed me about this the other day, and I thought it was on his computer, but actually this is our problem. Our simulate button is not activated. Okay, I can't simulate it. All right, we go to the next question. Cyrix Space says, I assume that it's possible to switch to SI units in RockSim because Imperial units don't make sense here. I can't remember where Cyrix was. Was he in Germany? Yes, he's in Germany. So let me go back to RockSim, and I'll show you how to do that. That's an easy one to do. Let me cancel out of this. Save your changes? No. Okay, so to change the units, so like right now, if I look at this in 2D, you'll see all my units are in inches. So go up to the preferences. So on Windows, I think the preferences are under the Edit menu. On the Macintosh, they're under the RockSim menu. And then just come down here to the preferences. And then go here to the tab called Units. And here you got a button here that says Use Default Metric Units or Use Default English Units. For me, I kind of mix and match because I think in grams, but in altitude, I think in imperial of feet or miles. So that's really easy to change. Just make that change here in the preferences. Okay, what else we got? Terry Wheelock says, can we design and simulate rocket glider with engines on the wingtips? I'm thinking about that, Terry. We kind of played with that before. Remember, if you go back to the Apogee website and go to the RockSim Live training page, and then come down. Okay, so episode number 69, can you simulate boost gliders in RockSim? And the answer was we could if you're in RockSim Pro. Again, this is another thing where you need 6 degrees of freedom. And I thought I had designed a rocket. Get rid of that since it's broke. I designed a glider, desktop, mini Condor glider, and I'm just going to open that in RockSim Pro. You could just grab and drag it onto the application screen, and it will open it up. And so this is my rocket glider. If you can see it right there. To make this screen right here bigger, you can move it up and down, but there's a limit on how far you can move it up. But you can detach this screen from the bottom and make it floating by clicking the little button over here. On the Macintosh, it's on the left side. On Windows, it's on the right side. But if you click that little button, it'll detach the screen, and now this screen floats, and now I can make it bigger. Oops, I just reattached it to the top. Okay, so here's my boost glider. And his question was, can you put the motors on the tips? And I've never tried it, but I'm thinking that you might be able to. You would have to put those motors into pods, and the pods you can put anywhere on the rocket. A pod is a collection of parts on the outside of the rocket. And I think you can put those on the wingtip, and so yes, you might be able to have them out there and design a rocket like that. I think that would be cool, Terry. I'd like to see you do it. Don't depend on me to do it. You can do it. I know you can. Kiko, I don't know where you're from, Kiko. Is it possible design? Oops, I just lost it. I was scrolling. Is it possible to design water bottle rockets? I have a final in my physics class and I'd really like to test out certain ideas. RockSim needs to transport, a rocket needs to transport cargo and land back safely. That's a hard question. But the answer is, if you are willing to work at it, the answer is yes, it can do water rockets. Okay, so to do a water rocket, okay, so I got this screen here. Let me reattach it. So to reattach it, you just drag it, and I just reattached it to the top. You can attach it to the top or attach it to the bottom. See, when I move it down here, you see the screen jump. That means I can let go and it will attach right there. Oops, it didn't attach. There it goes. All right, so I'm just going to minimize that. I'm going to be back in RockSim. Actually, I want to go to the Apogee website because there's a faster way for me to do this. Go to How-To and Guides. Come down here to Peak of Flight newsletter. Then come over here to All Newsletters. Click on that. And then this gives you all of our newsletter articles. Like I told you, we're on newsletter 574, which came out last week. And I did an article on how to do water rockets, and it's in one of these newsletters. And so which one? So this is a quiz. How do you find something on the Apogee website on a specific page? If you remember, do a Control F on your computer or Command F on the Macintosh, and it will bring up a little search bar up here at the top, and just type in a word, maybe like water rocket. And there it is, newsletter issue number 219, Create Water Rockets in RockSim. So if you open that up, what it will tell you, here's the start of the article. So that's kind of what a simple water rocket looks like in RockSim. But what you'll need, though, is a thrust curve for your water rocket. And creating that is the hard part. Like I said, this is going to require some work. So if you want something that's like done for you, it's not here. You got to do it yourself. You got to create this thrust curve and put it into Engine Edit. So this article explains how to do it, how to create the thrust curve, and then you load that into RockSim, and then you can run your simulation. And I think I did have some sample designs in here. See if I can find a link. I'm just scrolling through this article here, see if anything jumps out at me being a link. Okay, so here, download the water rocket design file from RockSim right here at this link. So you just click on that, and it downloaded it, and it opened it here. Okay, and so in the folder you get the rocket and you get an engine file. So if I'm in RockSim, remember to open rockets quickly. First you have RockSim open. You have that, oops, not that screen. That one. You have your browser open, and then you can just grab the rocket and then just drag it onto RockSim. You let go, and it's going to ask me, do I want to save that one? I say no. And oops, and it just crashed. I'll do it in RockSim Pro, see if I can get RockSim Pro to crash. Save your changes, no. Okay, it opened it up. And this is your basic water rocket. You got to add your own fins. And then you got to take this engine file and you got to load that. This is my crash log from when it just crashed here a second ago. You got to load that rocket into engine, or you got to load that into RockSim, and that's pretty easy to do. You just go File. Oops, I got to be in RockSim. RockSim or RockSim Pro, it's identical procedure. So you go to File, Import, Engine Files. And you just wait for it to come up. Okay, and then it's going to ask you where the engine files are, and I had them in my downloads folder. Allow. Okay, so here's the water rocket folder. Here's the engine file. RSE stands for RockSim Engine. So I can open that. And it imported it, which is good. So here it is, and then I just move it into the RockSim folder. So it added that water rocket right there. And now I need to add some fins to this design because otherwise it won't go straight. I'm going to add them to the tube. And I just add fins. Click cancel. So it added these big fins, so I'm just going to make them smaller. I'm going to be from the base of the owning part. Change my root cord length. Change my tip cord length. Change my semi-span. Oops, that's probably too small. And then I want to change the location. I'm sliding them. Oops, wrong direction. From the front, if I slide them this way, it should wrap around. It's trying to wrap. It found the point here, but it didn't wrap this curve. And click OK. Yeah, it didn't like that fin. Wow. And then I can load the engine, choose engine. I got to choose that water rocket engine. I got to find that. What was it called? Water rocket, water dash dot 90, water 90. Show all engines. I'm going to sort by engine code, and so it should be, oh, okay, there it is, the water rocket, W90 PSI. Make that 0. Click OK. It's loaded, and I'll just launch it. And sure enough, it launched and went 127 feet in the air. It crashed because it doesn't have a parachute in it. But at least you can get some data, so you can do water rockets, and I've kind of give you a sample design from that newsletter article. So that newsletter article again was issue number 219. So if you're on the Apogee website, to find that newsletter, go to How To and Guides, come down here to Peak of Flight newsletter, come to All Newsletters, right there, and then just scroll down until you get to 219. So we're starting at 574, and if I scroll down, I'm in the 300s, getting closer, issue number 219 right there, and then just click on that and they'll get you that newsletter article. Oh boy. We got a lot more comments here, but I don't think I'm going to get to them all because we're already out of time. Okay. Carlos says, an easy cheat is to find an airplane that goes your desired speed and do what they did. Okay, so there's some more comments. It doesn't look like any more questions. So we're gonna have to end today. My voice is going. We've already gone an hour and 10 minutes, so yeah, it's been a fun episode. Did a lot of stuff, a lot of little stuff, a lot of basic stuff, a lot of advanced stuff. And my screen froze. What happened? My screen froze. My camera froze, but I'm still here. Tim is frozen. Hopefully my voice is still going out because we're done. So we'll be back next week. Today is the 3rd, so 7 days would be June 10. Same time at 2 p.m. Mountain Time Zone. And that's 4 p.m. on the east coast of the United States, and 10 p.m. in Germany, 9 p.m. in England, probably 9 p.m. in the Netherlands. We're missing our Netherlands person today. Johan is missing. Johan, where are you? Yeah, so we'll be back next week. Thanks again for watching. I really appreciate it. And in 5, 4, 3, 2, 1, go out and launch something.